Diffusion, the international science radio show.
We have a bouncer on the doors of perception.
The good, the bad, the ugly.
It gets pretty exciting.
The myths, the truths.
Toxicology.
Astroseismology.
Magnetism. The dark side.
Genetically engineered potatoes.
Planetoid.
Planetoid.
I love that word.
Hello and welcome to Diffusion. Sit back and relax while we inject weird and wonderful science directly into your genes. I'm Ian Woolf. On this edition, we return to CeBIT to talk about artificial intelligence, autonomous cars, and the Hyperloop. But first up, here's the news. Milk that yeast. Back in 2015, I reported on a Californian company called MooFree. They were crowdfunding to engineer yeast to make casein, the milk protein that cheese is made from, so they could make cheese that didn't involve farming animals. The effort stood out because their stretch goals would make cheese for their donors using milk protein based on DNA sequenced from exotic animals, like the narwhal. Whatever happened to them? Well, they changed the name of their company to Perfect Day and will be launching animal-free milk, freshly squeezed from yeast, in late 2017. Bioengineers Paramal Gandhi and Ryan Pandya have engineered yeast to make some milk proteins when it ferments. They make lactoglobulin, lactalbumin, and 4 varieties of casein, but no lactose. They mix these proteins with a proprietary recipe of plant-based sugars, fats, and minerals to make milk without stabilizers, hormones, lactose, or cows. The yeast milk contains A2 protein rather than A1 for those people that are sensitive. The company claimed that Perfect Day milk is able to be used the same as dairy milk to make cheese, yogurt, milkshakes, ice cream, and pizza as good as the animal product originals. The DNA used by the yeast to make the milk proteins comes from a wet bioprinter that was programmed with the DNA codes for cow milk proteins taken from the full cow genome, sequenced and published in 2009. Perfect Day make the claim that making the yeast milk uses 84% less energy consumption, 91% less land use, and 98% less water consumption than typical industrial milk from dairy cows. Fermenting yeast fed with sugar to make milk proteins is similar to fermenting yeast to brew beer, once you've engineered your yeast. Turns out, Perfect Day is the name of the company because a 2001 study from Britain showed that cows give 3% more milk when played the song Perfect Day by Lou Reed, and they call their culture that produces the milk protein Buttercup. Now, the dairy industry has raised the question of whether the Food and Drug Administration in the US can allow Perfect Day to call their product milk. But I think that with soy milk, almond milk, coconut milk, and other non-animal products calling themselves milk, the farmers won't win the name battle. I hope Perfect Day will include cheese from narwhals on their product list when they launch this year. If you want to learn to use a bioprinter yourself, the University of Wollongong is running a free 4-week online course from the 26th of June at www.futurelearn.com/courses/bioprinting. I've already signed up. If you join up from listening to Diffusion, please say so in the course discussion. You're listening to Ian Woolf on Diffusion Science Radio. Send emails to science@diffusionradio.com. We're brought to you across Australia on the Community Radio Network and podcast over the internet on www.diffusionradio.com. At the Consumer Electronics and Business Information Technology Show, CeBIT, there was a pod-like autonomous people carrier and a more conventional looking self-driving electric Volvo at the Australia Driverless Vehicle Initiative stand. I spoke with their representative, Arjan Rensen, and began by asking, what is the Driverless Vehicle Initiative?
The EDVI is a collaboration with industry, government, research organizations nationally and internationally, and the purpose of EDVI is to make sure that Australia gets all the benefits from an early implementation of driverless vehicles onto Australian roads.
And you've got an example of a driverless vehicle here. I can't see any of the sensors.
This is a little driverless shuttle bus. This is just a display model. There is actually, you can see a few sensors on there. They work with cameras, laser sensors to basically read the road and to determine where to go, to stop and start for auto traffic and to avoid hitting obstacles.
And about how fast do they go?
Theoretically, they can go up to 45 kilometers an hour. When they are deployed in the real world, they normally deploy around 15 to 20 kilometers an hour. It's basically for the last mile from the station to your home or from the station to your office, and it basically replaces or walking or short trips on buses.
And the initiative is working on this kind of technology?
The technology is basically mainly developed overseas. We try to get Australia ready to deploy it on actual roads in Australia.
So how does Australia get ready?
There are a few challenges for Australia. One is that Australia is far away from the rest of the world. We only represent 1% of the global car market, and I think we need to create an environment that's attractive for overseas manufacturers to basically come and play in Australia. And when or if we are early adapters, there's a whole high-tech industry that we can build on the back of it. Universities, high-tech jobs. EDVI has done an economic outlook, and we believe that as an early adopter we could create 16,000 high-tech jobs.
And so we'd be importing these autonomous vehicles. Would they mainly be as buses?
I think one of the early, we call it user cases, you can call it applications, is driverless buses. You see them, they are deployed already in Perth, in Auckland, in New Zealand. There will be a trial in Sydney, and these RDM shuttle that is on display, they will be deployed in Adelaide later this year. That's the first application, but if you look at modern cars like the Volvo behind you, that's already a semi-autonomous car. It drives itself in city environment and on highways.
So with the Volvo, you drive it yourself for some other way and it knows the way for the rest?
The Volvo, unlike the shuttle buses that drive on a mapped route, the Volvo and other cars, they read the road. And there's some minimum requirements on the road environment, for instance line marking, for them to read the road and operate properly and safely.
Is the legislation ready for these sort of cars on our roads?
It's a bit of a grey area. The legislation says that a driver needs to be in control and a driver is responsible. So with the current semi-autonomous applications, the driver always needs to hold the steering wheel. That's absolutely critical. The driverless shuttle buses currently on the road, there's exceptions, but in all of them there is an operator who basically has the task to take over control when necessary and when required.
Is there a danger if the operator's not doing anything for most of the time that they could sort of fall half asleep?
It's an interesting question. Humans are not very good in monitoring a passive task, so they tend to fall asleep, get distracted. That's definitely an issue. That's been addressed by making sure that the operators are properly trained and they don't do very long shifts. I don't think we will need these operators for very long, because I think the technology will prove itself pretty soon.
And I guess the inevitable question is about what happens when things go wrong. Who's responsible?
That's one of the questions that need to be addressed. At the moment, the legislation says that the operator is responsible, but that's a discussion that needs to be addressed moving forward, because at one stage there might not be a driver at all in the car. And then the car is responsible, or the manufacturer, or the software supplier. That's an issue that needs to be resolved.
And what are they programmed to do if they think the car's in danger? Do they pick the pedestrians or the passengers?
That's an ethical discussion. There's a lot of people involved in the ethical discussion. I think there's opinions, but there are no solutions. I do have a personal opinion. I believe it's dangerous to program any computer to operate in a gray area. As human beings in traffic, we constantly operate in a gray area. I think my personal opinion is we should program a computer to be black or white and should always follow the road rules. Then the ethical discussion is do I hit a young family on the road or an elderly man on the footpath? I think there's a few things we need to consider in answering that question. The first one is that we teach people not to swerve because you can't oversee the consequences. I don't think a computer can oversee the consequences because you just can't see. And it's also important to realize that an automated car will respond significantly quicker than a human being. So the severity of the crash, if a crash occurs at all, will be significantly less than with a human driver. I think the whole discussion about autonomous vehicles is quite exciting, and if you start thinking what could potentially change in our life in 5 or 10 or 20 years, it's just mind-blowing. It could challenge how we look at urban planning, how we look at public transport. Electrification and automation go sort of hand in hand, so it will really change how we use petrol, but also all sorts of products related to petrol, like plastics, bitumen, and whole industry will change. I think our whole world might change as a result of it, and I think that's quite exciting. There is a lot of jobs will change. I wouldn't say a lot of people will lose jobs, but it will change. But it's a bit comparable with automation, because when automation and computers were first introduced, people were afraid that unemployment rates would rise, but in the end there's only more jobs today. So I expect that jobs will change, but I hope and I think that unemployment won't rise. That's sort of my main message.
And if people want to contact the Driverless Vehicle Initiative, how do they do that?
We do have a website. It's www.edvi.org.au. And please visit it, and every organization that wants to become a member of EDVI and be involved in the discussion, please visit the website and please put an application in to join.
Well, thank you very much.
Thank you.
That was Arjan from the Australian Driverless Vehicle Initiative. You can find out more at www.advi.org.au. I also saw a large pod next to some pictures of Elon Musk's retro-future vacuum tube high-speed transport system, the Hyperloop. Anjelo Fernando is an assistant designer at VicHyper. I began by asking him, what is VicHyper?
VicHyper was one of the first teams that actually got to test out in the Hyperloop system. We built a pod competing against 1,700 teams around the world. We came to the top 30 and we managed to build a pod, take it to Los Angeles and actually test it out.
So if we can go back a step, can you just briefly describe for the few people who don't know, who've been under a rock, what is the Hyperloop?
So the Hyperloop is it's an idea that's been around for a while. It's similar to having a train, except rather than having it travel on a track, you have it traveling in an enclosed tube. As soon as you pull out the air in that tube, you can reach to speeds much higher than the current trains can travel. Ideally, the upper limit is around 1,200 kilometers an hour. This means Melbourne to Sydney is within less than an hour is a very good possibility.
So that's faster than the very fast train.
It is much faster. The fastest trains you have is, I'm not sure the exact value, but it's around 400-500 kilometers an hour. So this can actually get you faster than a plane in some cases, because as soon as you consider the time of boarding in and stepping out, it's faster than a plane as well.
So the basic idea is that you've got a vacuum in the tube, like in the old days when they had vacuum tubes sending money and notes all around the cities in the 30s, and there's no friction, so you can go faster.
Correct. Mechanical friction is one of the biggest limiting factors as well, because that produces heat, which makes systems very inefficient. As soon as you get rid of that air in the tube, you overcome a lot of the frictions you have. And when you have a magnetic system, so it's floating rather than actually traveling on wheels, you get rid of the friction you have on your wheel systems as well. And braking as well has to be performed as propulsion through magnetic systems, because you can't have friction systems working in those cases as well.
So how do you brake when there's no wheels?
So what you're doing is, when you have a large magnet, you have it placed on the other side an aluminium plate. So your magnetic field can travel through a vacuum or through air. It travels into your aluminium plate, and that actually creates a field inside the plate, and that causes a magnetic drag that helps slow down the pod. It's similar to sort of dropping a magnet through an aluminium tube, where it doesn't fall down immediately but slows down as it goes down.
So Elon Musk is bringing students in.
So Elon Musk actually enabled the idea. He built the first test tube to actually test out the system, and he open sourced the idea and invited university students and anyone actually to build concepts that could actually work for the Hyperloop system.
And you had to compete for the privilege of going to see the Hyperloop.
Yes, so the first round was a design round, and in that case we had to put forward the design we hope to build. And from over 1,700 members, we managed to come down to the final 30, which got to actually build it and test it out.
And so what's next for you? You've built it, you've tested it, you've gone to LA, and what's next for the team?
So right now we've gone incorporated. Our MIT University is still providing us with a lot of resources to go forward, and we're looking at building the remaining technology to actually get the Hyperloop working and also improve the technology we've built so far.
Is there any interest in building Hyperloop technology in Australia so we can travel fast?
Yes, so the Melbourne to Sydney route is actually the most traveled overland air route in the world, but we don't actually have any high-speed rail traveling between the two. The Hyperloop actually gives you the chance to have passengers go over land at much faster speeds and also connect all the regional towns you have in between and have connected to Australia much better than we have right now. It's been a wonderful experience, and the Hyperloop seemed unrealistic when we started 1 year ago, but within 1 year we've learned what it is, and we've actually got scaled versions of prototypes running, so it's definitely not fiction. It's something that we hope to see very soon in the future.
Well, Anjelo, thank you very much.
Thank you for getting us out there as well. It's been nice talking to you.
That was Anjelo Fernando from VicHyper, designing the braking system for the ludicrously fast Hyperloop. My eye was caught by the robot of a startup selling artificial intelligence to businesses. Samir Sinha is the founder and CEO of RobonomicsAI. I began by asking Samir to explain what is RobonomicsAI.
RobonomicsAI is a technology startup that helps clients go through the journey of AI adoption. We integrate components of technology and offer it as a service. So for a client for a CIO or a technology head who's been asked by the CEO or the board, I've read AI can change my world, go do something about it, and they're scratching their head, where do we get started? That's where we come in. We look at their business. We look at how technology can help create new customer experiences for them, new business models for them. And then we look at what kind of technologies would be required to deliver those outcomes. Then we go to a set of our ecosystem of partners. We get the right kind of partners come together, and then we stitch together a solution which is built on our proprietary platform. These solutions would entail, let's say, an internet-connected device like a drone, or a wearable device, or a medical device that transmits data. That gets fed into an artificial intelligence platform that does big data analytics and prediction about what output or what could happen next. And all this is stitched together where we interact one-on-one with end consumers using our not-so-pretty robot. So overall, there are components that can actually come together to disrupt multiple industries.
But in this case, it's people coming to you saying, how can I apply artificial intelligence to my business?
Actually, it's more like people coming to me to say, I want to increase my revenues, or I want to cut down my cost, or I want to reduce risk, reduce injuries in my business. And then normally people would go about doing it using manual methods. The approach that we follow is start with automation. And we call it AI first. So whatever you want to achieve, if we start with automation, how would we redefine your business process? Look at multiple technologies, stitch it together, redefine that process. And wherever you need people interaction, human interaction, or wherever technology is not up there, that's where we use people. As opposed to, let's do it manually and sprinkle a bit of automation. We're going exactly the reverse way. Start with automation and then bring in people when required. A bit like the mobile first approach or the cloud first approach. So the new wave that's going to come on in the industry is essentially an AI first approach.
So it's designed for artificial intelligence from the ground up.
Exactly. That's right.
So that way it's not a filler sort of applied to gaps that might all fall apart later.
Yes, the fillers in our case are the manual methods. The core is automation. So it's a radically different way of delivering outcomes. Look, each of these component technologies has the potential to disrupt specific industries globally. We are taking these very technologies as the building blocks, and we are making them sing together out of the same song sheet. So the power that a user organization would get by integrating these powerful technologies is incredible. And the world is about to change with this approach. We are here to basically help the customers go through the path. You have two choices as a customer. In the wave of automation and learning from history, you can either be the horse-drawn carriage, you can either be the roadkill, or you can own the road. And that's what we are in business for, to help you own the road.
Well, Samir, thank you very much.
Thank you. Thank you. It's been a pleasure, Ian.
That was Samir Sinha at CeBIT talking about RobonomicsAI, helping organisations integrate artificial intelligence into their business from the ground up.
In countless ways, directly and indirectly, your product here serves the nation and its citizens, plays a vital role in helping every American to achieve a better way of life, enables or helps him to enjoy healthful recreation, have well-trained, obedient pets, make friends, have leisure time for travel, grow bigger crops, get real smoking satisfaction, strengthen our national defense, keep romance from fading away, enjoy smoother shaves, live in a more comfortable home, take off ugly fat, achieve success. Thus, Your Name Here story. A story of refusal to admit defeat. A story of gallant men and women who kept faith and who molded the universal dream of a better life into reality through your product here, the living symbol of our national heritage, and whose contributions to the betterment of mankind will never be forgotten.
And that's all from us this week on Diffusion. Would you like to hear your voice on radio? send a voice memo, or use the tab on the website to send an audio message. We need more people contributing stories to Diffusion. Send your contributions, opinions, helpful suggestions, and donations to science@diffusionradio.com. That's science@diffusionradio.com. And please do send me an email so I know you're listening and you'd like to hear more episodes. Please like the Diffusion Science Radio page on Facebook and rate the show on iTunes. Tell your friends. Follow me on Twitter @Ian Woolf. Be my patron at patreon.com/diffusionradio. The news music was Rynos theme by Kevin MacLeod of Incompetech.com. Checking production was Charles Willock. I produce Diffusion, which is broadcast around Australia to 27 stations on the Community Radio Network, including 2RBM in the Blue Mountains of New South Wales, 8CCC in Alice Springs and Tennant Creek, 2 NVR in Nambucca Valley, and 3 MBR in the Valley Border districts of Victoria and South Australia. Diffusion is syndicated globally on the National Science Foundation's Science 360 internet radio station and also on astronomy.fm. Subscribe to the podcast on the Diffusion website, www.diffusionradio.com. That's www.diffusionradio.com, and check the website for links, photos and videos about this week's show. If you enjoyed the show, you can explore more than 900 previous episodes archived on diffusionradio.com, where the shows are labelled by keywords so you can focus in on the stories you want to hear. Subscribe to the Diffusion YouTube channel at youtube.com/c/diffusionradio. I'm Ian Woolf. Join us inside your audio device of choice for more science wondering next week on Diffusion Science Radio.